Okay, imagine for a second those old world factories, the noise, the heat, the smoke. Now just wipe that slate clean. Think about a totally different place for industry. Silent, vast. Where the lack of something we absolutely take for granted, gravity, well, that becomes the key. Welcome to this deep dive. We're calling it the Orbital Forge, Manufacturing and Microgravity.
Hmm.
Today we're digging into something pretty fascinating, how weightlessness isn't just a problem for astronauts. It's actually a powerful tool, maybe even a revolutionary one, for making things. So our mission here is to explore how low Earth orbit is becoming, maybe faster than we think, our next industrial park. And we'll uncover some surprising stuff being made up there, materials, medicines, machines. Okay, let's unpack this. So let's maybe start with the basics, the physics of it all. Because it's pretty mind-bending. See, down here on Earth, gravity is just relentless. It's always pulling. So think about molten metal. Gravity pulls it down, causes imperfections, voids.
Seeing segregation, yeah. Heavier stuff sinks.
Exactly. It leads to sedimentation in solutions, making uniform mixtures, really hard to achieve. And it totally dictates how heat moves, convection. Hot stuff rises, cool stuff sinks. That's gravity at work.
It's a fundamental constraint in so many processes.
Right, but take away that pull, go into orbit, microgravity, and everything changes. I mean, everything. Liquids. They just form perfect spheres, no force pulling them out of shape.
Surface tension takes over completely.
Yeah. And materials, they don't separate by weight anymore. You can get these incredibly uniform mixtures. Crystals, they grow bigger, more perfectly structured.
Fewer defects, much higher quality.
And that convection heat transfer, it basically disappears.
Yeah.
Heat moves differently, through conduction mostly. It's wild.
It really is. And what's fascinating, what really grabs you, is how these seemingly subtle physics changes, they open up possibilities. Possibilities that can directly impact things you might use maybe sooner than you think.
Like what specifically? How does that translate?
Well, think about it. No gravity means no weight-induced limits on shape or uniformity. It means we can potentially make materials with incredible purity, better biological products, entirely new ways of making things.
Okay, so not just making better versions of Earth stuff, but maybe completely new things.
Exactly. Imagine trying to make a perfect, ultra-thin, hollow metal sphere down here. Gravity would just crush it. Or incredibly delicate lattice structures, impossible on Earth, but in microgravity, totally feasible. New geometries, new functions.
That idea of new geometries. That's cool. Okay, so give us a concrete example, something that really shows off this better in space idea.
Okay, a really compelling one is Z-bland.
Z-bland.
Yeah, it's a type of optical fiber glass. The thing is, when you manufacture it in microgravity, its performance is just dramatically better, significantly lower signal loss compared to the stuff made on Earth.
Wow, so like the data moves through it more clearly.
Precisely. Researchers highlighted how space-made Z-bland could potentially revolutionize data transmission because it's so pure and structurally perfect.
So the fiber optics carrying your internet could literally be made floating in space.
That's the potential, absolutely. Your future high-speed connection might owe a lot to orbital manufacturing.
Okay, that's a great example, but, it sounds a bit future tech still. Is this all just experiments on the ISS, or is it more than that?
Well, it's definitely moving beyond just theory. You'd probably be surprised what's already being done. It's practical, real-world stuff happening right now. And yeah, the International Space Station has been absolutely key.
The ISS.
Right.
Like a floating lab.
Exactly. It's hosted dozens, maybe hundreds of manufacturing experiments over the years, proving these concepts actually work.
Okay, so what kind of things? What are they actually made?
Well, bioprinting is a big one. NASA's biofabrication facility. They've actually 3D printed human tissue up there.
Human tissue?
Yeah.
Seriously?
Yeah. And the key is, without gravity pulling it down, the structure doesn't collapse like it can on Earth. It hints at, maybe printing organs someday.
That's incredible.
Alloy formation. Mixing metals. On Earth, heavier metals can settle out. In space, they mix much more evenly. That could lead to stronger, lighter alloys for aerospace, medical implants, you name it.
Better materials. Makes sense.
And pharmaceuticals. Companies like Merck have used the ISS to grow protein crystals.
Why grow crystals in space?
Because they can grow larger and more perfectly uniform crystals in microgravity. That structure is vital for understanding how drugs work and designing better ones. More bioavailability.
Huh. So better drugs, better materials, even human tissue.
Right.
But hang on. Getting stuff up there, isn't that insanely expensive?
Ah, yes. The launch cost question. Historically, that's been the huge barrier. Absolutely. Prohibitively expensive.
Right. So how does that square with doing all this?
Well, that's where things are really changing right now. You've got private companies, especially SpaceX, drastically cutting the cost per kilogram to orbit.
The reusable rockets.
Exactly. That changes the entire economic equation. It makes orbital manufacturing look much less like a government science project and much more like a potential business.
Okay, so the costs are coming down. That opens things up. Let's jump ahead then. 10, maybe 20 years. What does this look like? Actual factories in orbit.
That is precisely the vision, yes. Dedicated facilities, probably highly automated, just orbiting, producing things. Silent factories.
Who's working on this? Any specific companies leading the charge?
Oh, yeah. There are pioneers. Varda Space Industries is a big name right now.
Varda, what are they doing?
They're focused on pharmaceuticals. They launch these mini factories, make the drugs in orbit, and then have these little capsules that bring the finished product back down to Earth.
Wow, like a return delivery service from space?
Pretty much. And then you have companies like Made in Space, which is now part of Redwire.
Right, they did the first 3D printer in space, didn't they?
They did. The additive manufacturing facility on the ISS. And they're not stopping. They're working on tech for satellites that can actually build or assemble themselves once they're in orbit.
Build themselves.
Yeah.
Okay, my mind is officially slightly blown.
Mm.
So the potential applications. We're talking printing huge solar arrays in space, forging engine parts, semiconductors.
All of the above. Growing those perfect crystals we talked about, nanomaterials with unique properties, and maybe even building entire spacecraft up there. Spacecraft that never have to survive a launch from Earth. Imagine the design possibilities.
No gravity well to escape.
Exactly. And think bigger picture. Factories may be tethered by space elevators one day, or parked out at Lagrange points for constant sunlight.
Lagrange points, those stable spots in space.
Right. Continuous solar power. And the environmental angle.
Right.
Imagine moving heavy industry off-planet. No pollution here, no land use.
Using the vacuum and microgravity?
Turning the nothingness of space into our most advanced industrial park, it's a pretty compelling vision.
It really is. That zero pollution angle is incredibly attractive. But let's pull back slightly. It can't all be smooth sailing. What are the roadblocks, the big challenges?
Oh, definitely challenges. Huge ones. Launch costs, while coming down, are still significant. You have to get raw materials up there.
Okay, cost is one. What else?
Thermal regulation. Managing heat in a vacuum is tricky. It's not like Earth where air carries heat away easily.
Right, no atmosphere.
Material handling. How do you move things around precisely when everything floats? You need new robotics, new processes.
Can't just put your tools down.
Exactly. And then there's the whole legal and regulatory side. Who owns what rules apply way up there. It's kind of a gray area, a bit of a Wild West still.
That Wild West idea
Yeah.
that brings up more than just technical stuff, doesn't it? What are the broader implications for us down here, socially, economically?
Absolutely critical questions. Like access. Who gets to benefit from this? Will it be controlled by a few companies or nations?
Yeah, the ownership question.
And governance.
Yeah.
You have factories floating over countries, but not in them. Whose laws apply? How do you regulate that?
And environmental concerns in space itself.
Yes. What about space debris or deorbiting waste from these factories? We need to be careful not to just shift pollution problems upstairs.
And economically, could this widen the gap between those who have access to this tech and those who don't?
That's a real risk. If orbital production becomes the domain of a few powerful players, it could definitely deepen existing inequalities. These are big societal discussions we need to have.
It really makes you think. All these complexities, just because we remove gravity from the equation. But okay, despite the challenges, the potential, it does seem immense. Reducing pollution on Earth is a huge one.
Massive. Moving the most resource-intensive or polluting industries off-world. That could be transformative for the planet.
And creating materials we literally can't make here.
Exactly. Unlocking new technologies, new medical treatments through these unique materials.
Plus, supporting space exploration itself, right? Making parts in space, repairing things.
Crucial for long-duration missions. Think Mars. Being able to print spare parts or tools in situ, game changer. Makes deep space travel far more viable.
So it's not just about making things better, it's enabling entirely new possibilities.
That's the core of it, I think.
Okay, so let's bring this deep dive home. We started thinking about those old, loud factories on Earth, the industrial revolutions of the past. They were grounded, literally, messy, noisy. But this next phase, it's happening overhead, silently. The factory of the future might just drift. Tools floating, materials forming perfectly in zero-G. And this Orbital Forge, it's not just a cool sci-fi name anymore. It's like early days, but it's actively being built.
It absolutely is. And looking ahead, decades from now, microgravity could genuinely become our single greatest manufacturing asset. It could fundamentally change how we make things and what we can even imagine creating.
So what does this all mean for you listening? As we look up, it's more than just spotting satellites. It's about thinking how these quiet, floating factories might reshape, well, everything. Industry, innovation, maybe even our relationship with the planet and the cosmos. That next huge leap in manufacturing, maybe it's not about digging deeper, but looking higher, keep looking up. The next big invention, it might literally be floating up there waiting